Yeah, sure.
I mean, I wrote it down, but
Yep. I'll put it online anyway. The only thing I don't like about that is I'm not going to put a password in. Everybody can see what an idiot I am.
Mr. Brandt, don't say that.
Okay. Well, this is not really, it's okay.
How do you access it?
I'll send you a link
Okay.
to see. Okay. Now let's do 36,
37?
37. All right, here's the deal. Yeah, right. This brings up a good point. Here we go. Another one. Oh, it doesn't matter. So let's see. The light comes this way. Okay. It's a 43.5 minutes. Draw your normal at that point. All right. And so this is going to be 43.5 degrees. All right, that's supposed to be a dozen. Good, good, good. Coming in. Now, this is air. It's going to be glass. It's going to be water. Now, how's it bend? You're going to more dense material, right? So the heel is first, so it rotates like that. Now, is this what happens in reality? I don't know, but I know it usually works. So you do this. And this is going to be your theta I. Where's your theta R? The one connected with the normal. That's theta R. All right.
Wait, Mr. Brandt, I have a question.
It didn't bend much, did it?
No?
I don't like that. I'll take care of it in a minute.
Okay, so when you're going, why wouldn't it go down? Why is it going up in glass?
Well, this thing is bending. I didn't do very well. I'm not sure what you're asking either.
Okay, like why? So when you're going into like a more denser.
Mm-hmm.
So.
Well, think about
it. Like wouldn't it go down?
Well, that's what I was trying to do. I just didn't do it very well.
Oh, okay. Okay.
I said it didn't look very good.
Okay.
So we do this, but it's not going to be big enough to draw it is my problem. Let's make the glass a little bit wider.
Okay.
So I have room to do this. All right, now you're right. So it would bend, let's say like that. With me? That's more clear, right?
Yes.
That's your theta R. Okay?
But shouldn't it be going down? That's like going up.
I think.
Your heel hits, it bends that way. You were going this way, it bent that way. Right?
But it still has to be above the normal.
Okay.
Okay, that makes sense.
All right. It's probably good that you guys are here because the same people that are watching us, they're going to have the same questions, you know what I mean? All right. Now, and let's get that real quick. That won't take but a minute.
Wait, are you recording it right now?
Uh-huh. Thought it was. Oh, don't worry about it.
Okay.
Yeah. Yeah, good, because I don't want to be wasting time up here. That's for darn sure.
Okay.
Okay. Well, they don't see you, so they're not gonna, and I don't care about me that much. So, you know.
Okay. You're pretty photogenic, Mr. Ray.
Yeah, right. That's a polite way to put it, isn't it? All right, colorful maybe. All right. So now let's get that theta R. So we're going to do this. And just, it's supposed to be sine theta R, guys. I just don't draw very well. All right, so it's going to be, okay, let's plug in numbers, air. We'll probably going over this, but N of air. Close enough. It's not, once again, it's not exactly that. N times glass. Is glass 1.52?
Yes.
And we have water. I might as well put down water. 1.3. Are these 1.3 or 1.33?
1.3.
Okay. Now, again, did they say that?
Yes.
All right. Strange.
Sorry, interruption.
No, that's 1.3.
There is a blue Subaru parked over by the New Direction building or the parking lot across 14th Street that has been booted for being parked illegally. If you drive a blue Subaru that's parked across the street, across 14th, please go out there and visit.
Actually, they don't say 1.3. Actually, they don't talk about it at all.
Yeah, I thought it
Really?
did, but that's the distance.
Well, we better look it up real quick just to make sure, because I want to get dead on. Let's check. And let me just look it up real quick. refraction.
It's
646.
1.33, Mr. Wren.
It is?
Yeah.
All right.
See, or what's that?
So it is 1.33. So we used the wrong one on the other one?
That's all right. I mean, okay, as a final answer, we got 4.7, but the actual answer was 4.6.
Yeah.
I mean, it's not down, but
So, but we should have been using 1.33 then, right?
yes.
I'll put a little note on it later, okay?
But I mean, you're talking about it right now, so it's okay.
Well, this is not the same clip though. Yeah. All right, so 1.33. Gonna be for water. All right. And let's see, NR, and it's gonna be glass, so 1.52. Okay, guys, get me theta R then here, okay? So get that number, then inverse sign to get theta R. And tell me what it is.
$26.9.
That's what I get. What is that?
It's paprika.
Oh, is that your phone?
No, I'm not paprika.
Yes, and whatever you don't use last names here, whatever. Yeah, goober. All right, this is 26.9 degrees, okay? I'm gonna erase all this to do the second part here, okay? You guys good? Let's get rid of this.
Then 26.9 degrees would be
That
for
angle right there.
sine theta I, right?
That would be the theta for theta, the theta I prime. Now, here's my question for this, guys. Is it gonna, now here's the normal right here. Is it gonna bend towards it or away from it? How do you know?
Well, water is less dense, isn't it? Less
It
dense?
is, but I don't know that for sure, but I do know this. This is the thing that I tend not to get into. I do know. If you're gone, essentially you view this as though this substance is less dense if this index of refraction is greater than the one it's going into, okay? You with me? But it's going to bend away from the normal if this is less, if this index of refraction is less than this one. So it's going to, instead of going towards it, it's going to go away from it, okay? All right, everybody good? So let's have this, so there you're going to do this, right? And it's not going to do that much, but I exaggerate it. So this is going to be your theta R prime, and now this is going to be your, this is going to be your theta I prime, right? Theta I prime. Okay. And that's a plug and chug on that. Now, so this. And that's, you're plugging in, just make sure you have the right values for the right stuff. So, I'll write them in here real quick. So, this is glass, and glass is 1.52. Well, let's do this. Bring this down. And I don't want to rewrite it, so I'm going to do this. So all the angle stick, blah, blah, blah. Now let's plug in numbers. And glass, 1.52. Sine of, what was that angle?
26.9.
26.9? All over. 1.33 for water. And therefore theta R prime. Inverse sine all that mess there. Give me a minute here, Justin, I'll help you, okay?
Why would it be 26.9? Because this angle right here equals this angle right here. Like, if you do the square and do like that through it, these two angles.
I get 31.1, what's the right answer? That's it? Well, they get 31.2, whatever. That's fine, 31.1. And that's going to be that angle right there. Okay. And I like that problem because it tells you whether it's been away from it towards the normal by the index of refraction, which I tend not to go into. But you have to know. So once again, I'll end it with this. If your index refraction is less for the subset you're going into, you'll bend away from the normal. If it's greater, you'll bend towards the normal. And that's it. All right, not bad, guys.
Can you ever bend like below them?